Today we are going to extract paralytic shellfish poisoning toxins from shellfish. We're going to go through the extraction process through acid extraction and the L-cysteine conversion. So the acid extraction gets the paralytic shellfish poisoning toxins out of the samples, and the L-cysteine conversion is what converts the GTXs into what looks like to our ELISA's antibody, neosaxitoxin or saxitoxin. And that's what allows our ELISA to have more broad spectrum or comprehensive detection of the PSP toxins, because it will detect not only the saxitoxin backbone, but also the neosaxitoxin backbone. So essentially GTX-1, and 2,3, in addition to several other GTXs. And we validated this test with our ELISA test with the extraction in our 2019 paper, so you can check that out. What we'll be doing is we have a set of samples that was sent to us by one of our collaborators. They're already aliquoted out into 5-gram amounts into the 50 ml conicals. So we're going to start off, we're going to homogenize them, acid extract, and go all the way through the L-cysteine conversion. All right, so let's get started.
All right, so here we are at the first step, where we're going to grind up our 5 grams of shellfish sample to homogenize it. You want to be careful when you homogenize to very gently increase the power of the homogenizer so that your sample doesn't come spilling out of the tube. You want to mix it around until it's really smooth, so shellfish can be kind of chunky, and you want to completely homogenize it so it's all smooth. I'm using a VWR homogenizer here, but you can really use anything that you have to grind up your sample. You just want to make sure you disrupt all of that tissue so that all the saxitoxins in the sample can be extracted. You're going to want to clean your homogenizer between your tissue samples. I'm using warm water here, so I'll rinse it once, dump the warm water out, rinse it again, just to make sure it's really clean and there's no chunks of tissue left between samples. Next, you want to add 3 milliliters of acid to your sample. And you can use 1% acetic acid, that's what I'm using here, or you can also use hydrochloric acid. It doesn't really matter. The point is to get a liquid acid form in there so that the PSP or saxitoxins will come out into the supernatant. After this, you want to vortex for 30 seconds. After you've done this to all of your samples, so you've added the acid and you've vortexed all your samples, you're going to want to boil your samples in the 50 ml conicals for about 5 minutes. And you want to loosen the cap just a bit so it doesn't pop out. We then remove the tubes from the hot water bath and vortex for another 30 seconds and allow it to cool. That cooling step is important because when you spin it in the centrifuge, you're going to want to have nice separation, and separation occurs better with cooler samples. Here you're going to spin at 3000 G for 10 minutes to separate the pellet with the homogenized tissue from the acidic supernatant, and that acidic supernatant again is what's going to hold the toxins. After you've spun your samples, remove the supernatant with the toxins from the pellet. As you can see here, we have pretty good separation. If you find that your supernatants are not well separated, like they're really cloudy, or if your pellets are not very solid, they're loose or kind of sloshy around, you can spin it again for a few minutes. Again, it helps to have that centrifuge colder than room temperature to get good separation. I set mine for about 10 to 15 degrees C just to help the supernatants separate out from the pellet. We're going to collect that supernatant into a 15 ml conical and then set it aside. After you've collected your supernatants from all of your your tubes, we're going to repeat the acid, vortex, and centrifuge steps again. We're going to remove any extra saxitoxins that are still stuck in the tissue or in the pellet. So again, add 3 ml of acid to the 50 ml conical, vortex the pellet again for another 30 seconds, and then go ahead and centrifuge at 3000 Gs for 10 more minutes. So after your second spin, you're going to want to again check to make sure you have good separation and remove the supernatant from that second spin and add it to the supernatant you saved from the first spin in the 15 ml conical. Just as before, we want to be very careful not to disturb the pellet or take any of the pellet. I'm going to tilt the tube here so that I can very clearly see what I'm pulling up in my pipette. I don't want to disturb that pellet at all. I only want that clear or slightly colored supernatant. This is here just zoomed in. You can see I'm very carefully removing about 1 ml at a time the supernatant, the liquid on top which holds the toxins. After you've collected the supernatants, you'll have about 10 milliliters of liquid. And if there's any that's not quite up to 10 mils, you're going to want to add DI water so that the total volume of all your tubes is 10 milliliters. As you can see here in sample 1, it's slightly lower than sample 2, so I have to add a little bit more DI water to that tube. After you've extracted your PSP toxins from your samples, you're going to want to convert the gonyautoxins or GTXs so that the antibody can see them, so to speak. To do this, we're going to use L-cysteine. First, I measure out 0.075 grams of L-cysteine into a sample tube. You can use glass, or in this case I'm using a plastic 1.5 mil tube. And I want to weigh it out so that it's pretty exact. I'm going to shoot for 0.07 to 0.08 or plus or minus 0.005 grams. And I do this for all the tubes that I need for all my samples. Next, we're going to add 300 microliters of our extracted sample to the plastic tubes with the L-cysteine already measured into them. After we add it, we're going to vortex well to incorporate all of the liquid with the crystallized L-cysteine. It's not all going to go into solution at room temperature, but when you're done with all the samples, put them in a hot water bath about 70 degrees Celsius and heat for 30 minutes, vortexing in between. I usually vortex maybe 2 or 3 times, so every 10 to 15 minutes, just to make sure it's nice and mixed as it's in the hot water bath. Once you've done that, you're ready to dilute your samples if needed and run the ELISA.